First thing I see in this section here, I see an equation. It says if you have an exponential function like y equals b to the x, then you can rewrite that as x equals log of y base b. You can go back and forth between these two, from here to here, from here to there. That's what that means, the arrows I drew there. If you have this, you want to change it to that, you can. If you have this, you want to change it to this, you can. Now, I didn't tell you what the log function is. So let's say I came and I asked you this question. Can you tell me what the answer to this is? Or I gave you this for homework. Well, according to this rule, I'm going to call that rule number 1. I'm going to be numbering the rules. According to rule number 1, I should be able to rewrite this one, change it to what? 25 equals, notice when you compare this to that, b is the base is 5 here. The 25 is y. Y equals 5 to the power of x. Now, can you tell me what the answer? 5 to what power is 25? X will have to be 2. Now, my calculator does not have log base 5 on it. Most of them, I didn't say all of them. Some of them you can actually put any base. But most calculators don't have log base 5. They have 2 logs on them. LOG, which is log base 10. We'll talk about that next week. And the other one, ln, which is log base e. That's it. That's what you see. So if you need log base 3, log base 4, log base 5, we have to be creative. How are we going to find the answer to it? So I'll leave that alone for now. I'm not even going to use a calculator. Log 27 base 3 equals x. Can you tell me what x is? The question is really to what power? To what power we have to raise the 3 2? So the answer will be 27. 3 to the power 3, absolutely, because you can change that using that rule. 27 equals 3 to the power of x. 3 to the power of what is 27? X is 3. If I give you 2, I can find the third one just using that rule. Let's practice with it. If I said to you, what is log base 4 of y equals 3? Can you tell me what y is? Again, using this rule here, I can box it for you if you can't see it. Using that rule there, I should be able to write that as what? Y equals the base is what? 4 to the power 3. What's 4 to the power 3? Is it 64? Yep. Log, I'm not telling you what the base is. 32 equals 5. Seven, 10. Okay.
4, right?
4, are you sure?
I think so.
How'd you get 4, Ricardo?
4 times 4, 16. No, never mind. 2.
2? Yep. Because you can write that 32 equals the base, which is unknown, to the power of 5. Well, 32, can you write the 32 as something to the power of 5? Isn't it 2 to the power of 5, 32? So b must be 2. So I'm lucky where I can take the 32 and make it 2 to the power of 5. What happens if that's 30? Then we're all in trouble. That's when we have to go to these calculators and use them. But it's not going to be today. That's going to be next class. Section actually 4 is using that key, the log, and the 10 to the power. Section 5 using the ln and the one above it. If you have a scientific calculator, you got both of these buttons, the log and the the ln. So that's the first rule about the logarithmic function. So when someone asks you what is the log of any number, we ask you to what power I have to raise the 5 to, so the answer will equal 25. To what power I need to raise the 3 to, the answer will be 27. To what power, or in this case I'm looking for y equals the base, which is 4 to the power 3. 32 equals the base to the power of 5. So if I label them beside x and y, I can call b the base, I can call this the answer, I can call this the number. The number equals the base to the answer. So if you write them that way, the number for num equals the base to the answer. So when you go to log, you say, okay, the answer for the log is the log of the number to the base. So if you have a number, base, and answer, you can say the number, that's this guy, equals the base raised to the answer. I like that better. But if you want it like in English, if you have a number like this, can you tell me what the number is or the answer is? I say I can take the number and make it equal the base raised to the answer. And I should be able to solve for that. The number equals the base to the answer. So if I put this problem, what's my number here? My number is the 125 should equal what? The base raised to the answer. So 5 to what power is 125? Yep, x equals 3, correct? Yep. Log eight base b equals 3. Again, use that rule. The number equals the base to the power of 3. B is the base. That's a B. It looks like a 6 there. What's the base then? Base has to be 2. That's the first rule. Usually I don't really make that the first rule, but our book starts with that. And I wasn't happy with them. Let me take you back quickly so I can write the rules here in this section. There's 3 rules in this section. Remember what I said about exponential functions? Here's what exponential function looks like. The book failed to mention that, our book. And I'm going to graph it in a thick marker intentionally. I have a plan. This is what the exponential function looks like. B to the x. Right? I want it to bleed through the paper. I want to see it on the other side. Let's see if it bled through. Can you see it bleeding through? I'll make it darker just to show you. That's what the graph. So this is my exponential function. Well, the logarithmic function is really the inverse of that. Does anyone know how to find the inverse graphically? Inverse of any function graphically? You draw a line, y equals to x, right there. Yep, right? Oh. And I should maybe make my x and y axes bleed through. Where's my x and y axes? Here we go. Let's make them bleed through. I want to see them too. And to find the inverse of any function graphically, we take that paper now and we fold it along what? That purple dotted line. So if you fold that paper along that purple dotted line, what you're going to get is your inverse function, which is really the logarithmic function. The log is the inverse of exponential. So let's fold that paper and look at the inverse. I don't know if you can see the axes. Can you see the axes here? You barely can see them, but I'll put them in for you. This is the y-axis. That was the x-axis. See what happened to the graph? So the inverse, when you look at it, if you try to go back to this page, the inverse of this, and this will be the logarithmic function, it will look like this. And this point will be 1, 0. So this is b to the x. This is y equals log, or x equals log y base b. That's the inverse function. This is the log function. So here are the rules of the log. What's the domain for it? Can you look at it and see what the domain is? Do you have any graph to the left of the y-axis? Do you see anything on this side? Nothing. Does this even touch the y-axis? No. That's rule number 1. What's rule number 1? Can't take the log, doesn't matter what the base is, of a negative number or 0. Does not exist. Can't. That picture tells you my domain is to the right of the y-axis. That's rule number 1. If I bring my calculator back here, you can use yours too. Doesn't matter which one. Let's take the log of negative 5. Can you see it on the screen? It should give me an error, domain error. Can't be done. Clear. Where's the clear button? Clear. The log of 0. Can't do it either. Error. Domain error. Can't do it. Clear. The natural log of negative 7. Domain error. Can't. The natural log of 0. Can't do it. So you can't take the log of a negative number or 0. Remember with the exponential function, I think I threw the sheets away somewhere here. All exponential function, when I graph them, they went through the point what? 0, 1. Well, all log function gonna go through the point what? 1, 0. They're all going to go through that point. All the log function. It depends on the base. If the base is 4, the base is 2, they're all going to go through that point. That's rule number 2. The log of 1, doesn't matter what the base is, the answer is always 0. to any base is always 0. The log of 1 is always 0. We wrote rule number 3. I labeled it as 1 there. I said if you have what? Y equals b to the x, we can make that what? X equals log of y base b. I'm actually putting both sections together here because they're really together. So I'm going to do the properties of the log. So in the first section, they just mentioned these three. The second section, they add the rest of them. So I'll just add them all in on one nice clean sheet of paper. Make sure you have a sheet of paper that has all these rules on it. Rule number 4. Now let's ask a question about exponents. When you were doing exponents, here comes the line paper now for you. When you were multiplying a to the 4th times a to the 5th, what did you do with the exponents? Add them. It becomes a to what power? 4 plus 5. Well, guess what? Rule number 4 says the log of x times y base b. Since the log is nothing more than an exponential function, I should be able to add them. That's the log of x base b plus the log of y base b. I'm going to list all the rules first, then we'll play with them. 5. When you divide, what do you do with the exponents? If I have x to the 10 over x to the 5th, what do? You subtract them, yes. So when you have division, you can write that as the log of x base b minus the log of y base b. And the last one, when you have power to power, what do? When you have x cubed squared, what do you do with that? You multiply. Well, here, when you have log x to the power of n base b, we are going to multiply. But what that means is I should be able to take the power, move it to the front, and make it n times the log of x base b. So these are all the properties of the log in the sections 2 and 3. So now my goal before we leave this room tonight is to make sure we understand them. I'm just going to do a lot of examples on them. I'm going to throw the sheet back in and say which one of these properties we're going to use. And next time, next class, we'll do more with them. Everyone has these handy somewhere? Leave that sheet handy. I'll keep coming back to it. Maybe I'll keep it in my hand. I'll hold it here. So I'm just going to apply some of the rules and tell me which one you're going to use after I put the problem up there. Maybe I'll stick with this rule for a while, rule number 3. I'll do a few problems with that first. I gave you some problems before, but let's say I gave you this. What's log 81 base 3 equal to? So if you apply rule number, which one? 3, I should be able to write that as what? The number, which is 81, is equal to the base, which is 3 to the power of what? X. Can you write 81 as 3 to a power? Could the 81 be 3 cubed? No, 3 cubed is what? 27. Could it be 3 to the 4? X is 4. Let's try another one like this. Log y base 10 equals 0.1. So what are we going to have? Y equals what? 10 to the power of 0.1. Is it? Take your calculator, 10 to the power of 0.1. Is that a minus 1? Is it? Where's my calculator? 10 to the power. If you have one of those cheap calculators, by the way, y to the x is your power, or x to the y. If you got one of those like $10 calculator, that's okay. You don't need anything really fancy for this class. Is it? 10 to the power of 0.1, 1.25 or 26. Positive 1.26 approximately. Okay, let's make them a little bit more challenging. I have no idea what the answer to this is going to be, but let's try this. Log base 3, 27 to the negative 1 equals x plus 1. Solve it for x. I jump to the good stuff quickly. The number, which is 27 to the negative 1, should equal the base, which is 3 to the power of what? X plus 1. Now, can I solve it? Isn't 27 3 to what power? 3 to the third, yes. To the negative 1 equals. Can I write this 3 to the x times 3? Because what do you do when you multiply? Don't you add the exponents? So this is 3 to the negative 3 actually. You know what? I could have left it 1 over 27 here. Right? What am I thinking here? Maybe I should just left it 1 over 27. Might be easier. I mean, I can do it either way. But I think if I left it 1 over 27 instead of making it that way, it might be easier. So 1 over 27 equals 3 times 3 to the x. Let's divide both sides by 3. 1 over 81 is equal 3 to the x. (81) is 3 to what power? 4? So 1 over 3 to the 4 is equal 3 to the x. If you bring that to the top, becomes what? 3 to the negative 4 equals 3 to the x. What's x equal to? Negative 4. That was a good question. Wow. I like when I just throw a problem that goes, oh, let's try this. That sounds like a wonderful one to do. We'll do another one like this, not to this level, a little bit less. Try that one. Again, I'm just going back to rule number 3, everything. One at a time. Using rule number 3, it says the number in this case, which is what? N plus 1, the number. 8 is the base. Should equal the base, which is 8 raised to what power? The answer, which is 3. Eight to the power 3, 512. What is n equal to? 511. Okay. Let's try some of the other rules besides rule number 3. And maybe I will label which rule I'm going to be using. Like rule 4, rule 5, whatever the case is. The question here, simplify. Let's say we gave you log a cubed base 2. Tell me what rule you're going to use and what the answer might be. Can you see all the rules here? Which one?
6.
Rule number 6. It says if you get a power, you can move it to the front. So I should be able to write that as what? 3. So R6, rule 6. This should give me 3 times the log of a base 2. That's it. I can't simplify anymore. Let's try this one. Log base 5, the square root of x. Again, what rule are you going to use?
Would it be 6 again?
Would be what?
Would it be 6 again?
6? Oh, rule 6 you mean?
Yeah.
Why rule 6?
Get rid of the square root, you can square
Put
it.
the square root in the front.
But how do you get rid of the square root?
Square root is equal to the half.
That's it. That's what I was looking for. Yep. It is rule 6 actually. Because this can be written x to the 1/2. I was looking for that. Base 5. Square root means the power of 1/2. Now take rule number 6. Yes, it is 6. And move the 1/2 to the front. So when I ask you the question, usually I don't mean like, no, you're wrong. I just want to know what you were thinking. 1/2 log x base 5. Let's try another one. Log base 2 of xy over z squared. This is going to be more than one rule. What is the first thing that you see? I see a big fraction, division. Do you see it? So maybe rule number 5. So if I apply rule number 5, it should give me the log of base 2 of the top, which is xy, minus the log of z squared base 2. The log of what's on the top minus the log of the bottom. Some of you probably see the 2 here. Go, I got that. That's rule 6, right? So if you apply rule 6 next, we can take the 2 to the front. Am I done simplifying? Which one?
4.
4. Double multiplications. Isn't it xy x times y? It says 7. There is no rule 7. Okay. Log base 2 of x plus log base 2 of y minus 2 log base 2 of 7. Oh, z, I'm sorry. That's what you meant, I think. That's a z. If that's what you're asking about the 7, that's a z. That's as far as I can go with this problem. I could have done the multiplication before I used that rule 6 there, and that's fine too. One more. Log base 9 of a cubed over the square root of x. Rule 5, you said? Yeah. Okay. So rule 5, which is division, it says the log of a cubed minus the log base 9, I forgot the 9 here. And I can make the square root what? X to what power?
1/2.
1/2, yes. Next is I'm going to do what? Rule 6, right? So if you apply rule 6 there, it's 3 times the log of a base 9 minus 1/2 the log of x base 9. Again, my goal for tonight, to make sure you understand these rules. That's my goal. So I'm playing with these. Now let's work backward. Let me give it to you in this format. Put it back into this. Go back and forth. Because you can go back and forth between them. So let's take, we'll begin with this. Log base 2 of 3 plus log x base 2. Here's the rules. Again, look at them and see which one. So now we're going to go from expanded to shrink them into one log, if we can.
Rule 4.
Rule 4, you have addition. That means it used to be what? Multiplications. Doesn't matter if you put parentheses or not, but that's what it means. It's log 3x base 2. Let me put a little twist in this one. I'm going to reverse this. The book doesn't do it, but I'll do it. By the way, I didn't put a base. That was intentional. Not one. Notice this calculator does not have a base on the log. Can you see it? That's known as the common log, log base 10. So if there is no base, it's always base 10. So that's log base 10. So if you put it or not, it's not a big deal. The minus sign is bugging me there. There's a quick fix to that. What do you think?
Multiply by -1.
Well, you could, but it's not an equation. You can only do that if you have an equation.
Multiply by negative.
No multiplications. Multiplication, you can only do that if you have an equation. You multiply the left side and the right side.
Can we
Or if you,
rearrange it?
that's what I was looking for. Rearrange that. How about log v first minus log r? I bet you not go, I can do it now. Nobody says you can't move them around, right? This one first, this one second. So what's your answer? Log number 5, yep, v over r. Right? Let me try another one. Two log 2 base 5 plus 3 log x base 5 minus log 3 base 5. So what are we going to do here? These numbers in the front, remember them? They used to be what? They used to be power. So let's do that. What would you have here? What is 2 squared? 4. Don't write it 2 squared. I mean, you can do 2 squared, but go back and finish it, make it a 4. This used to be x to what power? 3. Now, order of operation, when you have addition subtraction, you go left to right. What do you see here? You see addition. Addition used to be what? Multiplications. Minus. Now what do you see? Subtraction. That used to, as rule what? 6, 5, whatever? That used to be division. That's what that problem used to be. Let's try another problem like this. Then a few more things, then we're done. 1/2 log a base b, I'm using b for base, minus 2 log 5 base b, minus 3 log x base b. What's the first rule? What do you think? 6? Yep, okay. The 1/2 used to be the power. When something is raised to the power of 1/2, it means the square root. This is 5 squared, which is what? 25. And the last one is x to the power of 3. Left to right. Rule what? 5? You have subtraction. Used to be what? Division. That's again subtraction. That used to be rule what? 5. Again, it's this one divided by that one. So if you simplify this, this is over 1, right? The quickest way to simplify a problem like this, the outside times the outside, the inside times the inside. So that would be square root of a times 1, square root of a, 25 times x cubed, 25x to the third. It's always the outside over the inside when you have a complex fraction. The other thing we might give you is something like this. Solve for y. I know you're tired, but give me a couple more minutes. Log base 2 of y equals negative 2 log base 2 of x plus 1 plus log 7 base 2. If you don't like to start with the negative, you can flip-flop these two. And I think that's what we suggested early. Rewrite them. Flip-flop these two. If you flip-flop them, you'll have what? Log 7 base 2 minus 2 log x plus 1 base 2. Isn't that the same thing? We can take the power now and move it to the top using rule number 5. And what's next? This will be log y base 2 equals subtraction that used to be 7 over x plus 1 squared. I'm looking for y. It says solve for y. Well, this side equals to that. We have the log on both sides. We have the base the same on both sides. The only way the two will equal to each other if what? If y equals 7 over x plus 1 squared. That is the only way. I'll try another one, like this one. Oh, I'm out of paper. Don't worry, I got a stack of them in. Log base 3 of x plus log base 3 of y equals 1. Solve for y. What do you see? You see addition? So it used to be what? Multiplications. Now, how are we going to solve this? I need to solve it for y.
Maybe multiply each side by log base 3.
That won't cancel the log base 3. Look at rule number 3. Rule number 3 is the one you want to use when one side has the log and the other side doesn't. The log only on one side. Rule number 3 says I should be able to rewrite that problem as the number equals, my number in this case xy, equals the base, which is 3, raised to the answer, which is 1. That's how you cancel the log. Xy equals what? 3. Can you solve for y now? Isn't that 3 over x? Yep. So anytime you only have the log on one side, you really want a flag to go in your head. Rule number 3. That's the only way to get rid of the log. If it's on both sides, you can just drop it. It shows up on both sides. If it's only one side, you can't just drop it. So to cancel it, we use rule number 1. One more like this, and that's it. I'm not putting a base, which means base 10. Oh, I made a mistake. That's supposed to be equal. Chapter 13. To the 22nd. Okay, what do you think we should do? Can you use rule 6? Oh, I could make a y square here. That's what you want to do? Okay. Okay, I can do that. I have no problem with it. What else now?
Subtract log y squared.
Oh, so you're going to move it to this side. I like that. Bring it to this side. Make it a minus. So this becomes log of x minus log of y squared equals 4. So he's trying to combine the log into 1. So now we're going to use rule what? That's log of x over y squared. Remember, if there's no base, it's always assumed to be what? 10. So now, how do we get rid of the log here? Notice the log only on one side, not on both sides.
Rule 1.
Not 1. Well, we called it the first time 1, but it became number 3. Right? So that becomes x over y squared equals the base, which is 10 to the power of 4. That's a 10,000. Multiply both sides by y squared. I made this problem. I like it. What's y squared? X over what? 10,000. And how do you get y? Square root, you mean? Square root. And which means that's the square root of x. What's the square root of 10,000? 100? That's it. Next time we're going to actually use them somewhere. But I don't want to use them till we understand, we know how they work. The rules of them. What can you do, what can't you do with them. and you'll see some real problems next time where we use them in growth and decay, and you'll see, what about if I'm looking for something that I can't do with rule number, like again, let's say I ask you the log of 12 base 5. Good luck. Can't do it. So we have to use the calculator for that, so that's next class.